All right, guys, number 11. And before I get into the question, number 11, number 12, and number 13 is all from the applications of normal distribution. So I'm going to do each question in a separate video, but each question will build off of the same type of concepts that we did for questions 6, 7, and 8. Now, let's get into the question. It says, assume the distribution is normal, which means we're going to be using a bell-shaped curve. Use the area of the normal curve to answer the question. Do not round your answer to the nearest whole percentage. Sure thing, Captain. It says the average size of a bass and lake. I can't read. The average size of the bass in a lake is 11.4 inches with a standard deviation of 3.2 inches. You want to find the probability of catching a bass longer than 17 inches. Okay. So because it's normally distributed, let's draw our normal distribution curve. Or we can say the bell-shaped curve. Okay. Now, you don't have to draw it if you don't want to. And I won't draw it also in every video as well. But I like drawing it. That's pretty good. Now, remember, in the middle goes the mean. The mean is going to be 11.4 inches. Now, some professors, depending on how you teach the class, you will see two different types of symbols for your mean. You will see mu, which is the population mean. And then you will see X bar, which is the sample mean. For this class, it kind of doesn't matter which formula that you're going to be using to calculate your z-score. But for the purpose of keeping consistency, also with Alex, I'm going to use sample information. Anyways, the standard deviation is 3.2 inches. So that means every time we move to the right, we're just adding 3.2. So this is going to be 14.6, 17.8, and this will be 21. As we move to the left, we're just subtracting 3.2. So that's going to be 8.2. That's going to be 5.0. And that is going to be 1. Oops, careful with my math. That is going to be 1.8. That is 1.8. Now, let's continue. It says, find the probability of catching a bass that is longer than 17 inches. So we want to find the probability that our bass, which I'm going to call X, has a length that is greater than 17 inches. Let's find out where 17 will fall at on this curve. 17 will fall right about here. And it says longer than 17 inches, which means my direction is indicating to the left. We're going to shade to the left of 17 inches. Now, to find the probability of something that is normally distributed, we will be using the z-score table. However, for us to use the z-score table, let me clear this. We need to have a z-score. And right now, we don't have a z-score. But we can find our z-score from the question. We can convert our raw data into standardized data by using the z-score formula. So, z is equal to, in this case, I'm going to use x minus x bar, which is the mean, divided by s, which is sample standard deviation. I'm going to write it up here. Sample standard deviation. Some instructors, which I'm also going to write here, will write it as z equals to x minus mu over lowercase sigma. And lowercase sigma is the population standard deviation. In this case, it kind of doesn't matter which formula that you're going to be using. So I'm going to write it also in words over here. Z equals to the value that is under examination minus the mean divided by the standard deviation. Let's find that z-score. Z is equal to 17 minus the mean, which is 11.4, divided by my standard deviation, which is 3.2. Open my calculator. Let's do some mathematics. 17 minus 11.4. That equals to 5.6. 5.6 divided by 3.2. Z is equal to 1.75. And please make sure that your z-score is rounded to 2 numbers after the decimal. Now we're going to find the probability that z equals to 1.75. So let's go into the z-score table. 1.75. Here's 1.7. There's the 5 above. That is going to be 0.9599. This thing is annoying. Don't stop there, because this is not your answer. Remember, every probability on the z-score table is the area that is shaded to the left. However, in this case, it says longer than 17 inches, which means the area is shaded to the right. And to find the probability of right shading, you take this probability and subtract it from 1. So the probability that a bass will be longer than 17 inches is 1 minus 0.9599, and that equals to 0.0401. It wants it as a percentage. So when I make that into a percentage, that is going to be 4.01%. You can multiply that by 100 if you want to. So this number right here, 0.0401 times 100, gives us 4.01. And because it says it wants to the nearest whole percentage, this will be rounded to 4%. And the answer to this question is 4%. I'll put it up here as well, 4%. All right, guys, that's it for this video. This question doesn't take too long to do, actually. I'll just go in really into detail to make sure that you guys understand it. Like I said, you don't have to draw the curve. You could have easily looked at what it says longer than and know it is shaded to the right to still subtract the probability you get from 1. But if drawing a curve helps you out, then by all means, go for it. All right, guys, take care.